I'm really sorry, in the last video I mistakenly clicked the stop button, so we'll just continue from where we left previously. So I was telling you about this reaction. In this reaction you can observe that a single reactant breaks down to give simpler products, right? So this reactant is nothing but a mix up of, or an addition of, all these reactants. See, this has Fe, they have Fe. Okay, this has O, they all have O. This has S, this they all have S. So they combined will form this, right? If all of them are combined, they will eventually form FeSO4. So a complex, this is a complex product, right? These are all simpler products. Now these are very small and simpler products. Okay, so a complex product broke down to give out simpler products. That is a decomposition reaction. A single reactant, or you can simply write, a single reactant breaks down to give simpler products. A single reactant breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals lose water when heated and the color of the crystals change. It then decomposes to ferric oxide, sulfur oxide and sulfur trioxide. Ferric oxide is a solid, while SO2 and SO3 are gases. Okay. So decomposition reaction is nothing but the breakdown of a reactant to give simpler products. You can simply write it down, write its definition like, decomposition reaction is a reaction in which a reactant breaks down to give simpler products. Okay. Calcium oxide is called lime or quicklime. It has many uses. One is the manufacture of cement. So this is a calcium. This is this is an equation where you can see the reaction of calcium oxide. So what does this form? What does this make? CaCO3, which is in solid form. It gets heated up and then it releases quicklime, that is calcium oxide here in solid form, plus CO2 gas, carbon dioxide gas also. Another example of thermal decomposition reaction is given in activity 1.6. Now you can read this example just to clarify the previous definitions again. And now this is an activity you can read by yourselves. These activities are actually somewhat important from the examination point of view, as they are mostly asked in examinations. But we will read this activity 1.8. Take about 2 grams silver chloride on a china dish. China dish is nothing but a simple kind of a porcelain dish, a dish made of crystal, the simple crystal that you have in home, or the special kind of dishes that you use to serve to guests, right? Those are the china dishes. I'm not talking about a crystal like a ruby or something like that. What is its color? Silver chloride on a china dish. What is its color? Place this china dish under sunlight for some time. Observe the color of the silver chloride after some time. You will see that the white silver chloride turns grey in sunlight. This is due to the decomposition. Decomposition means breakdown of silver chloride into silver and chlorine by light. So decomposition can be summed up as nothing but breaking down of the molecule. So here it was, what was it? Silver chloride, silver Cl chloride breaks down to form silver plus chlorine, right? Chlorine is released as gas and silver is left there. This was another example of decomposition reaction. All right, now we move to displacement reaction. Displace means to remove something from a place and put something else there, that is to displace, or not even to put something else, just simply take one thing from somewhere and put it somewhere else. There's no need to put anything in its place. So like moving on, we take actually two. Let's first read this activity. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 milliliter copper sulfate solution. So it has copper and sulfur in this solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. Okay. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solutions in test tubes A and B. Also compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. So after you put two iron nails into copper sulfate solution and remove them after 20 minutes, you would have to notice the color of the water of this solution, and also the color of the nails, right? There must be a significant change. So this is a copper sulfate solution in test tube B, and this is the second test tube in which the iron nails were put. So you can clearly see that the color has changed. And what has made this change in color? Obviously it's the iron nail. And similarly the iron nails colors have also changed. This is the new color of that iron nail, this is the original iron nail. You can clearly mark the difference between both of them. Why does the iron nail become brownish in color and the blue color of copper sulfate solution fade? Right? So here I've written a small note regarding this. I think this might be helpful. Let's read it. Copper has displaced iron. So copper has displaced iron. These were what? Iron nails. And this was what? A solution of copper. So copper has displaced iron. And where there was iron coating on the nail, there is copper coating. So since copper has displaced iron, so copper has taken the place of iron. Right? Copper has been put up at the place of iron. That's why the iron nail has become now copper nail. It means at least there's a kind of polish on it, a copper kind of polish. It's not completely copper nail, you can say, but a copper has taken the surface of the nail. There is copper coating, and where there was copper solution in the test tube, there is now iron solution, and this is now a ferrous solution, that is iron solution, whereas it was previously copper solution. So this copper has been transferred into the nail, and the nail's iron has been transferred into the solution. This is called a displacement reaction, right? So you may say that there is no particular definition for displacement reaction. A displacement reaction is nothing but a kind of reaction in which one element, one chemical displaces the chemical of the other substance or of the other object, in which one chemical displaces another chemical, right? Iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Displacement reaction is a reaction in which one element displaces another element. Zinc and lead are more reactive elements in copper. They displace copper from its compound. So the more reactive elements will always displace the lesser reactive elements. Double displacement reaction. This is double displacement reaction. Take about 3 milliliter of sodium sulfate solution in a test tube. Sodium, that is NaCl, sorry, your Na only, sodium sulfate, and to be specific, sodium chloride is nothing but your common salt that you use in your veggies and your food. That's NaCl, and this is Na sulfate, right? In another test tube, take about 3 ml of barium chloride solution. Mix the two solutions. What do you observe? Now we will mix both these different kinds of solutions together, and they are asking, what do we observe? You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as precipitate. So the insoluble substance that has been formed after the mixing of sodium sulfate and barium chloride is called precipitate. Any reaction that produces such a precipitate can be called precipitation reaction, right? So any reaction that produces precipitate can be called as a precipitate reaction. Now the most important reactions are double displacement reaction is not that important, right? Displacement reaction is also not so much important, but it is a bit important. So the most important reactions, however, are this decomposition reaction and combination reaction, and of course oxidation and reduction. Now oxidation and reaction, these are our most important topics. So heat a china dish containing about 1 gram copper powder. This is pure copper powder, nothing else. What do you observe? The surface of copper powder becomes coated with black copper oxide. Okay, why has this black substance formed? So the surface of the copper powder becomes coated with a kind of black substance. Now that is nothing but copper oxide. Okay, and what is copper oxide? Wherever there is oxide, simply just take it for granted that this is a substance of oxygen. Okay, oxygen has been added to it, oxygen was added to it, or oxygen is added to it. Oxygen was there, oxygen is there. Wherever there is oxide, oxygen is there. Okay, wherever there is oxide, just take it that there is oxygen. So copper oxide means copper and oxygen. Since there is no other element in between this, there is simply copper and oxide. Oxide here stands for oxygen with mixed with a with another element. So this in this case it has been mixed with copper, so it becomes copper oxide. Now why has this black substance formed? Due to the addition of oxygen. Previously there was only copper powder, there was no oxide, right? So there was no oxygen, there was only copper. Now this has become copper oxide due to the addition of oxygen in it. This is because oxygen is added to copper and copper oxide is formed. If hydrogen gases pass over this heated material, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. Now this black heat in this black surface can again be turned brown, can again be turned back into pure copper. How? Through passing hydrogen gas over it, right? Because hydrogen will mix up with oxygen present in copper oxide and it will convert into water. And then what will you have? You will have water and copper. You have pure copper plus water, right? Not a mixture of copper and oxygen. So that's why they're saying if hydrogen gas is passed through it, right? Like see here, this is CuO, that is copper oxide, plus H2, that is hydrogen. This is in the form of a gas. Plus this is heated now. This is heated again, and it forms copper. This is pure copper here. Cu plus H2O. H2O is water. If a substance gains oxygen during a reaction, it is said to be oxidized, right? Oxidized. If a substance loses oxygen during a reaction, it is said to be reduced, right? That's why oxidation and reduction. So oxidation means the adding of oxygen. Oxidation, that is oxygen addition. You can take oxidation as oxygen addition, and reduction as reduction, or simply reduction, simply reducing something. Reduction or subtraction means subtraction of oxygen. Oxidation is addition of oxygen, reduction is subtraction of oxygen. Okay, that's an easy way to remember it all. So during this reaction 1.29, this is 1.29 reaction, the copper oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. So this is not just a case of copper losing oxygen, copper being reduced. This is also the case of hydrogen being oxidized or hydrogen gaining oxygen, right? Both the things are happening simultaneously here. Here copper is losing oxygen while H2, that is hydrogen, is gaining oxygen. So the hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the other gets reduced during a reaction. Such reactions are called oxidation reduction reactions or redox reaction. Redox means reduction and oxidation. Reduction, oxidation, reduction, oxidation mix up to form redox. And what is redox? It means it has both of the things. It has reduction in it and it has oxidation in it. Reduction and oxidation, and both are happening at the same time or in the same reaction. This is an example of redox reaction. Some other examples of redox reactions are these. This is zinc oxide plus carbon and it forms zinc plus carbon oxide, and this is MnO2 plus HCl, and these are some different reactions, right? Now if you want to read, these are actually very easy. There's not even any need to read them, but just if you want to, you can. So corrosion, a metal is attacked by a substance around it such as moisture, acids, etc. It is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. This is corrosion when a substance is being attacked by substances around it. It can be anything, and it corrodes. That process is called corrosion. Now rancidity, when fats and oils are oxidized, that is fats and oils gain oxygen, they become rancid and their smell and taste change. Usually substances which prevent oxidation, antioxidants, are added to foods containing fats and oils. You must have heard behind every package, almost every product which you buy from the market, it contains antioxidants. When you will turn it around and read it in the ingredients, it will mostly certainly will have antioxidants added to it. That is to prevent rancidity, so they can last even longer. Their shelf life improves. Okay, so this is the chapter ending and it's finished.